Gentlemen, okay, ladies and gentlemen, today we have this is our second example, example B. This is looking at the growth of the U.S. population in millions over the time in year. So our X's are our years, our Y's are our population in millions. And we can go ahead and we know from this, so population is going to be on this axis. And years are going to be on this axis. I had to do a little break there. So 1800, 1850, 1900, 1850, 1900, 1950, 2000. So let's go ahead and look at our scatter plot. So we're going to go back and use the calculator again. So I'm going back here now. We are going into our menu because we have to switch ones. Again, you're going to put them in, go into graph. I stored my variables under year for the years and pop for the population. You can see I have them right there, so I'm going to turn off this one and turn it. Okay, off that one. Okay, again, menu, again, I'm going to use. Then I'm going to use fit, and here we can see it. Now, as you can see this one, I'm going to go ahead and plot it really quick on in our other place. We're going to use red, and we could see okay. And yes, definitely has a positive direction. And it is a strong association. You can very clearly see this graph. However, you can tell that it is curving up. So this is non-linear. So being it is non-linear, doing correlation would not be very effective. It would be weak correlation. It's not linear. But perhaps we can straighten it out. Now, normally, straighten it out. We can manipulate one of the data sets to see if we can get it to straighten out. We're seeing something that is somewhat exponential. So let's go back to our calculator. All right. And you can see first thing I did here is, okay, try to take the logarithm of the population. I restored it as population 1. And it gave me another set of values. So we can go back in and I'll use that to create a scatter plot. Go back to the graph. So we'll go into our scatter plots. And this time, year is still going to be there. And now we're going to use pop 1. Turn that one on. I know. Why do you do this? As I told you, just bear witness with me, ladies and gentlemen. Looks a lot straighter, but I think still curving the other way. So I think this one reversed itself. Still not very helpful, this one. So let's go. Okay, so that didn't work. Let's try to take the square root. This time I started under pop 2. Going back into here so we can go into our scatter plots. Again, it's still year. But now it is going to be pop 2. And this one looks much straighter. So we'll go ahead and use this one to do our regression. So we need to go back and fix our graph a little bit. So I'm going to go ahead and erase this one. But now it is the square root of the population. So we got to change the name of our axis. All right, and now we have points looking like you can see a much straighter correlation, much straighter line there. So by changing our variable to square root of the population, we get a much straighter variable. And we can go ahead and use our calculator tools again. So coming back to the calculator. All right, this time we're going to have to call the linear regression tools. So we're going to go into our menu, statistics, stack calculations, linear regression A plus BX. This is year. Remember, this is now pop 2. I'm just going to call this equation 2. Okay, and we see a very strong correlation, which shouldn't come as about as 0.995. So we now know that the R value for this one is going to be 0.995. So we're looking now at a strong, actually a very strong correlation between our variables. Between year and the square root of population. And we can say this is a very strong correlation between year and the square root of population. Now we can include that it is linear, but the word correlation, remember, only refers to linear. And that there is, ladies and gentlemen, is example 2. And you should have a textbook assignment for tomorrow, also due tomorrow. Thank you very much.